Okay, so 1 second. Okay, I made a little video on rationality or a little interlude on rationality, and I don't know if I'm going to make it a video or interlude, whatever. But I made a little interlude on whether or not or how to detect rationality from decomposition groups, and now I want to give you Machizuki's definition. Machizuki's definition of this x underline. Okay, so for x a punctured elliptic curve. Okay, so definition, according to Machizuki, so this is Etale Theta section 2. Okay, so let x be a punctured elliptic curve satisfying our hypotheses. Okay, so our hypotheses were that K had all the L torsion points, and another thing that he assumes later, but I don't think we need this now, is that that the image of the Galois representation contains SL2 FL. Okay, so let x be a punctured curve satisfying our hypotheses. Okay, so then and fix some quotient Q. So I guess I should also say that this isn't how he presents it either. It's a little bit more confusing than the way I'm saying it. No offense. Okay, well I think it's personally easier. Okay, so let x be a punctured elliptic curve satisfying our hypothesis, and fix some quotient such that three things hold. Okay, 2, 3. Okay, so f factors through. So let's say pi abelianization x. And then we take this thing. So let's say mod L. Okay, so I did these lemmas to show that these things made sense. Okay, and so okay, what does this thing actually mean? So actually, I think we actually need actually I need to call it L. Okay, so there's actually this other group that he defines, and so let me just say a little bit about what this means. So this means that the kernel contains let's say Q. I call that Q. Kernel contains this gamma 2 of delta of x. This is the second term in the second term in the lower essential series. This is this is the second commutator, right? I O tilde over O. This is the inertia group of the origin, and then it also contains delta of x to the L. So these are the ith powers, and then you span this and make this normal subgroup. Okay, and so you have this quotient, and it factors through this thing, and this thing is the quotient of pi of x by all this crap. Okay, so the other thing that we have is that when we restricted the abelianization. Okay, so I do this bar, and do this, and a mod L is surjective. Okay, so what this is really saying is that you take the abelianization, you surject. So this is like if you identify this with the L torsion, then this is saying it's a quotient of the L torsion. Okay, and then the third thing you have is that Q applied to this decomposition group, dO tilde over O, is equal to 1. Or maybe I could say 0 or 1, but okay, and what we saw before, that this will tell us that the cover determined by this quotient is actually going to be rational. It's going to be k rational from what we said before. So what do we say? So x is a point. So x is a punctured elliptic curve satisfying our hypotheses. Okay, and we fix some quotient such that this crap holds. So then we define. So I guess I have to go to the next page to finish this definition, which is kind of bad. But we define the cover xu, so x underlined to x, to be the what did we well, yeah, the cover corresponding to this quotient, the Galois cover, the Z mod L cover corresponding to this quotient, quotient. Okay, and that's his one of his versions, but this is in prose, and then it's I don't know. You have to kind of figure out that all these are these things and what the definition of this is. But I do prefer the previous definition that I gave. Okay, so that's all I wanted to say about Machizuki's definition. This is what it is, and then I guess you can go and try and cook up what this cover is and see that my definition is the same as his. Well, I mean, it's not really too difficult, I guess. This is the thing about the torsion that I said. This thing's about the rationality. So this is kind of interesting because this allows you to impose conditions about rational points just in terms of the groups. So I guess this part here. Not actually sure where this came from. Maybe this is just a matter of fact. I think maybe you can reconstruct this one from 2 and 3. Yeah, so definitely, yeah, I think you can construct one from 2 and 3. Okay, so, all right.